Hey everyone, in this video we're going to talk about the Joint Optimal Pro application toolset, which has actually a really fun acronym, but for Russian users only. It's called JOPA or JOPA. Doesn't really matter, it's a bit of a humor on my part. So who is this tool for? This tool is mainly for riggers or game animators who actually do rigging as well, besides animation I mean. This is the tool for quick and convenient rigging, essentially. Creating skeletons, creating joints, and setting orientations and other operations with these joints. There are a lot of scripts over here which are combined in one common tool, which can be used for essentially different characters. So first we create bones or joints, place them in the right positions, and then we do orientations. This is the exact sequence in which it's supposed to be done. And according to this principle, the scripts are divided into 3 zones. It's the making of joints, the second zone is like bone alignment, and the third one is the joint orientation. And additionally, there are a lot of other kind of useful tools which can be used for different tasks, which we're going to talk about a bit later. Also, the important part is that I actually do game animation I've been doing game animation for more than 20 years at this point, and of course all these principles, all these tools have been tested on actual projects, on production-ready projects. And I'd say that this toolset is sufficient for most of the tasks. There aren't any unnecessary tools. It's kind of bare minimum which is required and very useful for creating skeletons of any complexity. Let's actually start using this script, an actual example of this dragon. I'm going to show you how it works. At first I'm going to click this button. Essentially it's the standard button for creating joints in Maya. So let's place a few joints, let's say along the tail, like this, like this, like this. Of course I've selected those joints, I've pressed this button for this. This button highlights, essentially selects entire hierarchy, and it selects only joints, so it means if there is something else inside the hierarchy, like locators and stuff like that, it's not going to be selected. After that, I'm going to press this button to make the correct size. This sets the size of the bones according to their length, the joint length I mean. And the button next to it sets the size with relation to the distance to the camera. There are also kind of standard buttons for increasing and decreasing the size, so you can use that for changing the size of the joints. Alright, so let's say we have this joint chain, and for this tail it's not enough. Right now I've just used these joints in order to set the kind of average length for this joint chain, but the number of joints isn't enough. Now we can use these buttons in order to add or remove joints from the chain. And the script right now is trying to keep the shape, the overall length of the joint chain, but it adds more kind of subdivisions, adds more joints. Let's add a few more. Well, let's say that's about it. You can add more, you can add less. And I'd say that the tail is ready. Alright, so essentially right now we have necessary and correct positions for these joints. Next we should orient them. But let's talk about the orientation a little later. Let's talk about creating joints at first. Let's say you have something a bit more difficult for joint creation, not something straight as, let's say, the tail example. Maybe you have a leg which is kind of curved or bent slightly in some places. You see, in this situation you can select the geometry, you can select vertices, then you can press joint on center button. It essentially creates the joint in the middle of the vertex selection. And in this case you can either select the vertices or you can select faces if needs be. And you have to remember that these joints are going to be created in the sequential order as those components have been selected. But what if, let's say, this method doesn't suit you? Maybe you have a very specific example, maybe you have something a bit more difficult from the anatomy point of view. There is another type of bone or joint creation. Let's say you created a joint. Then you can use inside joint in order to create the joint inside this joint. Then you can press the G button in order to repeat the last operation. So essentially creates the joint in the same position as the selected joint, and you can use it in order to populate some body part. And of course you can add in and remove joints as well. Next, I hope this functionality is quite clear. I think that's it with the tail. Let's move on to the leg. And also, as you can tell, our joints are centered, so it's not positioned exactly in the position of the tail, but actually it's kind of easy to tweak. Let's leave it as is for now, and let's work with the leg. Let's create a joint. Then I'm going to turn on the Snap to Project Center button, and then I can quickly press in a few places and to position new joints. Yes, something like this. Now, again, I can select the entire hierarchy, increase the size, and of course, like this, we should move our joints because the first one isn't positioned in the correct place. So I'm going to select it. Right now we're not paying any attention to positions, to orientations. I mean, to orientations mainly. We're paying close attention only to positions. Let's say I like this position, I like the positioning of my joints. But of course we need to make it so these joints are actually positioned in one plane. It's usually desirable and preferable for IK systems, pole vectors and stuff like that. For that I have this section. At first we have to select the joints which we need to kind of reorient in one plane, or reposition rather on one plane. You can select either the hierarchy or you can just select a few joints. But in this case it's better to use all the joints, to select all the joints. Then you can press this button, and as you can see, all the joints are going to be positioned approximately, with certain approximation on one single plane. Or I can cancel that and I can use this method. I can also align my joints with global space coordinates, or global space Y, and it's being aligned based on the first joint selected. So let's say if I select in this order, then align, you see it's going to be aligned relative to the first selected joint. You can use this like this, or you can actually set an absolute value. So I'm going to set a tick box absolute, and it's going to position it in absolute value on X, Y, or Z. Of course, we can do the same with the tail if needed. I'm going to select the hierarchy, I can align the joints, and you see we have the result. Let's say it doesn't suit you, and it very well may be the case, because in the next example we're going to talk about the joints, placing joints for fingers, and there are certain situations which are not as simple as the situation over here. There is a button which is called Align Manually. You can see it over here. So we select the hierarchy of joints, press this button. You see that the plane has been created, and now you can tweak this plane in order to achieve necessary results. So essentially you can rotate this plane and rotate entire joint hierarchy following this plane. I can also press the button and select the first object in the hierarchy, first kind of locator for this plane. And then I can reset the pivot to the last object in the hierarchy. Also tweak the position, tweak the rotation rather. If I press this button, the pivot is going to get back to 0. And also you can tweak and position different joints, like separate joints, relative to this plane. So it's very straightforward. First you position the plane, then you can position joints themselves as necessary. After you're done, you can click the del button, as it's over here, and everyone is happy. Let's take a quick look. Let's take a quick look on our tail. Let me add a few joints to the tail. Let's say I don't like these joints, don't like maybe joint positions. I can move it over here. Then let me select the entire hierarchy. Also, you see there is a button which is called Smooth Position, which essentially smoothes out the positions of the joints and makes them so they are kind of in, they have the same distance between each other. You see, I'm going to select this joint. Let's say we moved it like this. Then I'm going to press this smooth button with the selected hierarchy. You see it kind of interpolates in a way in order to smooth the joints positions inside the chain. There is also an align distribution button over here. This button is going to set the same distance for between joints and entire hierarchy. And it means that you can actually move joints to a specific selected joints, kind of interpolate it in a certain direction along the chain, or you can just smooth it out completely and make the same distance between the joints inside the hierarchy, inside the joint chain. Again, it's very commonly used in tails and stuff like that, so it's a very common task to do. It's also very commonly used in clothing, rigging clothing, also creating joints and stuff like that. Because clothing in games not often isn't often divided into equal sections, so it's kind of a very common tool to work with. Alright, let's say now we have these joints positioned correctly. Now I want to change the joints orientation and continue working. How can I do that? That's the next step we should work with, orienting joints, right over here. What do we need? But first we should select an axis in which the skeleton will be oriented. So it's essentially the forward axis. In this case I'm going to select also z-axis is the up axis, and the tail is positioned along the positive y value. So let's say I want to use the y-axis in order to orient my joints along the joint chain. And let's say I want to do it for now just for the tail, because I'm going to talk about other parts a bit later. I'm going to select the y value and press the orient button. Now you can tell that the joints have been oriented. By the way, over here I've made a mistake when I moved the joint manually, right over here. It kind of offsetted, it is offsetted slightly to the side. I can align it again in absolute coordinates. Then I can press the true orient again. You can now see that we have our joints axis displayed, and we can see the orientation for our joints. Also, there is a little remark over here. Many people will look at it and say, so what's the big deal? There is a standard Maya tool for orienting joints. You see, this tool works, the standard Maya tool, I mean, works fine when the joints are kind of positioned in the world space. In those situations, yeah, it's orienting joints correctly in most of the cases, so it's alright. But for the objects like this, like the leg, for example, it's going to orient kind of horribly. In this regard, this tool is far more convenient, it's far more reliable. I think the only kind of issue, or rather kind of nuance to when you're working with this tool, is that it's not entirely clear what axis should you use in order to orient your joints. So in most of the cases you have to kind of test it out, you have to try different orientations, try z-axis, x-axis, because this joint orientation highly depends on the situation. Well, mainly actually on the rigorous, I'd say, preference, but there are some unique situations. It doesn't really matter right now. Let's say we want to orient our joints like this. Maybe we don't like it. Maybe we should change the axis and try to reorient the joints again. Or we can do it like this. Or like this. There is also a type which is called manual correcting, and over here you can tweak the rotations manually, tweak the orientation manually. So let's say I want to rotate the orientation around its own axis right now for the joints, and I can just click the button a few times, and maybe it's fine for me like this. You can do it for the entire hierarchy, or you can do it for selected joints. Now give me a second, let me undo a few things. So let's say this orientation is sufficient for me, I like it right now. We can do the same with the leg. I think in this case it's supposed to be kind of bent in a Z, in the negative Z direction. So for this example, let's select the entire hierarchy. I'm going to use negative Z value, and I'm going to press the button. So if I set all zeros, if I reset the rotations, the leg should be straight, and it means that it works fine. And then if I do the same for the tail, I'm going to reset the rotations, and it also looks fine. Usually it means that the axis orientation is correct. Axis that you selected for the orientation. Right now I can see that I have the rotations only in one axis, because my joints are kind of aligned in one plane, which is good. The last bone, the last joint, has 0 rotations because it's kind of world aligned. By the way, the standard my tool for orienting joints actually ignores the last joint in the hierarchy, so this tool is definitely better. Now you can do the following. You can actually switch to the naming button. You can either change the name by hand, just manually as in the usual manner, or you can use this set of tools in order to change the name, add suffix, add prefixes. I'm gonna set it like this, and you see it's a left back leg. Then I can set some kind of naming for the tail joints. Again, it's a bit subjective, it depends on the project and your naming convention, but let's say like this is fine. By the way, you can also change colors for the joints, just for your convenience. Or maybe you can also disable the local rotation axis, like this. Let's work with the fingers. Of course, over here I have kind of complex design for the fingers. So it's better maybe to set joint over here. I think it's supposed to be over here. Yeah, and the last joint is going to be over here. Then I'm creating joints based on selection. Again, it's virtually the same process. Also, those joints, you see they're positioned not exactly correctly. Well, I can use the smoothing position to kind of average out the position for these joints. Or I can use the plane orientation to fix the position for the joints. So let's select the entire hierarchy, let's press this button. The plane is going to be created, then I can tweak the plane rotation and tweak the joints rotation. Of course, it's not always possible to use vertices and faces and to create, to use those positions for the joints. At least you can use it for the base, for the starting point, and then you can tweak it using different tools from this tool set. Let's say it should be fine like this. To be honest, this joint orientation is slightly an overkill because it's a bit too far. I mean, I'm orienting joints right now is a bit too much because it's not necessary for this kind of design. Let's orient it like this. Let's show the local rotation axis. If I zero the rotations, it should be fine. Okay, let's keep it simple. Let's move on. Let's continue working. Let's add other joints for the second finger, second claw, maybe rather. Let's position it like this. Over here. Okay, the same over here. Then I can orient joints. I think yeah, it's positioned correctly right now. Yeah, I think it's supposed to be over here. And of course you're going to do the same for the rest of the fingers. Then I'm going to use the P button to parent my joints to the necessary joint. Then I can select the entire hierarchy with the fingers included. Then I can turn off the local rotation axis. The next step slightly depends on the personal workflow, your personal preferences, because at this stage you can freeze rotations on your joints in order to transfer the values from the rotation channels into the joint orient channels. You can do that, or maybe let's say for some reason you don't want to do it, you don't want to transfer your rotation values to the joint orient values, maybe you want to use it for some other purposes. For that, for this case, you can select the joint, then you can find a button that is over here. It's called Orient to Rotate. You see it sets the rotation from the joint orient. So essentially it means that you can freely freeze the rotations and get those rotations back from the joint orient if needed. Again, it depends on the result that you want to achieve. For example, on the fingers, sometimes it may be useful, maybe when your fingers at the base are slightly bent, but then after you set all the joints, you want to kind of make it straight, make your fingers straight, so you zero out the rotations without freezing them. Let's move on. Let's work with the neck and the head part. Sorry. Let's use the create joint tool. I'm gonna create a few joints. So let's start with maybe with the spine. Actually, I think it's gonna be like this. It's supposed to be spine, chest over here, is over here. Then the neck base is supposed to be over here, then the neck starts. Yeah, I guess something like this. Of course, right now we have maybe not enough amount of joints, enough number of joints over here, and in the neck as well, so I think we should add a few more. Let's do it. Alright, so we essentially smoothed out the positions, we added additional joints. Now the joint chain looks much better. Then I'm pressing the button and smoothing it out more. Maybe then I can make a bit fewer number of joints, something like this. Let's think about the neck. Let's say if we want to zero out the rotations right now, is the neck going to be kind of horizontal, or it's supposed to be set vertical? Let's try, maybe it's up to you entirely. Maybe let's try doing it this way. I'm going to orient the joints. After that, I'm going to zero out the rotations for these joints. Let's take a look at how it looks. Ah, of course, yeah, sorry, my bad. Because let's do the same with the spine, because this kind of one joint hierarchy. Alright. Yeah, I think it should be like this. Let's zero out the rotations. Yeah, you see it's... oh, sorry, if I set it over here, I'm gonna set it to 0. Yeah, it's being set vertically. There is another kind of useful tool. You can select two joints and then select the joints in between. So you're going to select the first joint, then you're going to select the kind of last joint or some kind of joint, and then you're going to press the button and it's going to select all the joints in between. And it works in a way that it selects the shortest path from one joint to the second one and selects all the joints in between. And it works in different hierarchies with any complexity of hierarchies, so it works fine in most of the cases. You can then rename the joints, so maybe paint skin weights, let's say, or something like that. Doesn't really matter. We can set a color for these joints. Okay, what else can we do? Let's say I want to make additional joints for this part. Maybe I want to make some additional, add in some new joints in order to control the scales of the dragon, which it has on the neck, I mean. Or maybe in order to have some additional control over the neck sections, neck parts, maybe some, you know, soft tissues and stuff like that. I can select a couple of joints. Then I'm going to select the joints in between. Then I'm going to press this button, and then I'm going to offset these joints, maybe like this. Then I'm going to do the same. I'm going to press this button and offset to the other direction. Of course, I can still tweak the individual joints if it is needed. You can also smooth the positions of these separate joints. It's going to work fine. Yeah, like this. And of course, you can do the same with the same joints on the same line, which are placed, I mean, on the same line. So you can smooth the joints positions regardless of the hierarchy, essentially, which is great. After that, I can continue and orient those joints. Alright, those are now oriented correctly. And you see those are oriented kind of as if they are in one chain. Maybe if you need a very unique joint orientation for some specific mechanisms, things like that. Of course, it's not really necessary, but it can be done if needed. Alright, let's try working with the wing. It's going to be fun. I think, yeah, it's a bit more convenient to just place the joints in necessary places. I think there are very distinct places for placing these joints. Let's select the projected center tool, snapping tool. Then I'm going to place joint over here. I think it should be over here and over here as well. Let me increase the size a bit. And also it is highly preferable to place those joints on a single plane, because you see right now they're kind of scattered. It will not work properly for the animation. I can try using the kind of automatic approach, but you see it doesn't give me a necessary result. So let's tweak it slightly. Yes, so let's tweak it at the base a bit. Then I'm going to highlight the hierarchy. Let's now orient those joints. I think they should be oriented along the positive X value, I think. Because if I set it to 0, I think the wings are supposed to be set in kind of T-pose or something like that. Let's try figuring it out. Again, as I said, these axis orientations are usually hit or miss, so you should try different variations. Again, I think it's the only drawback with this toolkit, because it's not always possible to understand how axes are supposed to be working, so how you should orient them. Okay, let's continue. Let's place other joints. This time, let's try placing those manually. Maybe I'm going to place a joint over here, then another joint over here. Yeah, maybe like this. Again, now, although those joints are kind of outside the hierarchy, you still can orient those joints as if they are in the single joint chain. So we can orient those joints like this. Again, we should try finding we should find the appropriate axis for those operations. And then you can use the special button, in order to parent those joints inside the hierarchy, inside the single joint chain hierarchy, I mean. Then you can select the entire hierarchy, orient it again. Let's parent this to the wing, to the main wing joint. And now that is actually the case when it's very useful to work with a joint orient setting. I mean, transferring rotations from rotate channels to the joint orient and vice versa. Because maybe I may not want to have my rotation zero out for the main wing joint chain in order for it to be set in a necessary pose, but it actually may be beneficial for the other joint chains which are attached to the main wing chain. You see, I've reset the rotations, and now maybe in a zero pose they're going to be set like this. Of course, after that you can rename those joints. Again, naming convention is entirely up to you, so you can decide on that by yourself. Then I'm going to parent the wing joint, the main wing joint, to the spine. I think it actually makes sense in this case. Then I want to mirror all these joints to the other side, on the other wing. For that I can use the multi-mirror button. The settings for this tool are essentially the same as the standard Maya settings for mirroring over here. And essentially right now we have the rig that is almost ready. Of course, there are still some things to do and a lot of things to do, but overall it's very easy and fast process. Now let's talk a bit more about orientation again, specifically on the manual orientation. Let's assume we have a joint. Let's create one over here. Let's create another one. Alright. So let's say we have this joint chain. Right now those joints are oriented by default. But maybe I want to make it so that some joints from this chain have maybe non-standard or special orientation. This often happens when you want to orient certain bones or joints in the geometry by hand, and of course you can do it. So I'm going to select some joints. It's possible to rotate this axis by 90 degrees in one axis or another. There is also a tool, a special tool over here, which essentially activates the rotation tool, and we can rotate the channels, rotation axis as we wish. Maybe like this. Right now I can see that all the joints have the same orientation as before, except the one that we've kind of edited by ourselves, edited manually. Okay, let's continue. There is another possibility, another opportunity, so to speak. It's called the proportional rotation. So when you are selecting the bones and you want to rotate those proportionally, kind of with a different degree relative to each other, so to speak, you can activate this mode. And now by rotating the last joint in the hierarchy, you see all the other joints up the hierarchy are going to be rotated proportionally. So those are going to be rotated in a spiral manner. You can also tweak the first joint in the hierarchy and again create an additional spiral rotation, something like this. And of course it's not really necessary for this joint chain to be straight. Let's say let's apply the changes, then let's try apply the tool again. Maybe we want to rotate this chain in a very specific manner, maybe something like this. I can still apply the same modification, the same tool, and the shape of this curve is going to be saved. So it's not only for the straight lines, essentially. Alright. There's another tool in the orientation tab. Those ones over here. So let's say we have a bone, have a joint. Let's make a few joints, maybe like this. Give me a second. Yeah, like this. Yeah, let's say I have something like this. I'm gonna enable the local rotation axis. It's a very common task when you need to orient your joints in a way so the joint is kind of oriented towards the parent joint. So there is a child joint and it's oriented towards the parent joint. So we can highlight the joint, one or more joints actually. Then we can apply the orient joint from parent function. It's going to orient the joints based on parent, but with the axis that is selected over here, in those settings over here. So in this case it's going to be positive axis. And the axis is going to be rotated from the parent, kind of facing away the parent, kind of along the invisible axis in this case. Right now I can see how those are rotated. Usually it's a very common task when you're making kind of fans or something like this, like, you know, katanas from Mortal Kombat, Kitana's weapon. Maybe when you have a minimal number of joints, of bones, you need to rotate those quickly. Alright, let's move on. The next button, which is called Orient Joint from Child, it works in opposite manner, so essentially it orients the parent to the child, so kind of based on child. Again, it uses the same settings, the same axes, which are set over here, and then if we apply this function, you see right now that the rotations of the joint have been changed, and of course everything inside the hierarchy remains the same. I mean, everything that is under this parent joint. Of course, you can still use a manual tweaking, manual rotations in order to tweak the rotations as you see fit. The next group of tools, they're kind of standing on the sidelines, are the tools that are the tools over here. Usually those scripts are exceptionally useful for creating joints for mechanisms, for some mechanical characters, robots, and things like that. The question is, what's the point of this tool? Because it's very often you can just create joints and that's it. You see, it's a very common case when the model consists, for the robot, I mean, consists of some separate objects like shafts, gears, things like that. So those are the objects, those are the mechanisms that are supposed to be moving in a very specific manner, very precisely. Very often the character artist, or it doesn't matter, the 3D artist, he makes some kind of 3D model of a mechanism, and in the process the artist rotates the mesh components in the correct way, but then he merges all these components in one single mesh, zeroes out the rotations, orientations, and you kind of have to have a way, to return those rotations and set correct positions for your joints. As an example, let's say I have this gear. There is nothing we can essentially base our joint's position and orientation on, because we need to position it quite precisely in order for the mechanism to work properly, but there is nothing to work with. But we need, let's say, a joint precisely in the middle of this mechanism. You see, there are several ways to fix this problem, and those scripts are precisely for solving such issues. Of course, the first thing we can do is to select two opposite faces, if there are any, of course, and then place the joint based on the center of these two objects. But of course, this base joint isn't rotated, isn't oriented correctly, so we have to fix that, and it will take some time. We can do the following instead of that. We can try evaluating this mesh, try thinking about how can we base our rotations, how can we rotate our axis for the joint. So essentially, how does it work? We're selecting three objects. The first button, which is located over here, yeah, right over here, it's going to select first two selected objects and then position the joint exactly in between those two joints, and it's going to orient this joint, this newly created joint, based on the third selected object. Let me show you. I'm going to select three objects, then I'm going to press the button, and then you're going to see that I will have a new joint which is oriented towards the third selected object. Yeah. Of course, after that you can do some manual tweaking, you can add some additional rotations, orientations, well, essentially you can tweak it as you like, using other methods that we have looked at previously. The logic is this. Now we can take this joint, we can skin this joint, and you'll see that this gear, yeah, it's directly rotating around its own axis, so it works perfectly. So that's how the first button works. I think it's pretty simple and intuitive. The second one, it's kind of very similar, but has some differences. Again, you are selecting three objects. Again, your joint is placed in between the first two selected objects. But when it comes to orientation, first of all, your primary axis is going to be oriented towards the in-between the first two selected objects, and the secondary axis of your newly placed joint is going to be oriented towards the third selected object. Generally speaking, for this gear it doesn't actually matter because we are supposed to have our center of rotation in the center of the geometry, so it's fine. But let's say if you have some kind of other mechanism, some cubic mechanism, which is supposed to have its center of gravity somewhere offset or something like that. For those tasks, this second button is better. Now let's move on. The third button virtually is the same, but again there are some differences. Again, we're selecting the three objects, or three components rather, in this case. In this case, the joint is going to be placed or positioned on the third selected object. The primary axis of this joint is going to be oriented towards the first selected object, and the secondary axis of this newly created joint is going to be oriented towards the second selected object. So that is how it's going to be directed. It also happens to be very relevant for a lot of cases. Let's actually move on. Let's go to the fourth button, which is called C in this case. I'm going to use this object as an example. It's a bit trickier to work with, so I think it's going to be more representative. It's a very common thing when, let's say, three artists created an eye geometry, then he actually cut the geometry in half, because the other half is kind of inside the head and we don't need it, so we have an eye, essentially eye geometry. But you need to place the joint in a position of a hypothetical sphere, which this eye was made of. So it's supposed to be right over here, approximately, and back in the day I was forced to kind of eyeball it, sorry, no pun intended, to find the necessary position for this pivot. So again, for this function, you're going to select the three components, and again, I'm not talking about the objects, I'm rather talking about the components, so it's edges, vertices, or polygons, faces. And what does the script do? It creates the center of rotation based on these three selected components, so for these three selected components. So it kind of projects center of rotation and creates the joint on the position of this center of rotation. Let's actually give it a shot, and you'll see that we have now joint, which is positioned in a kind of hypothetical center of a sphere. Let's say, what if you need to both position and orient the joint? You can actually use a very simple trick. You can create a new joint. This joint is going to be created on the position of the vertex, so it's essentially the center of an eye in our example. And then we're just going to orient the first joint towards the new one. Then we can delete the second joint, and you have a necessary result. You see it's oriented correctly. You can rotate it as you wish, so it functions like an eye. And next, let's talk about the last button in this tools. This function actually, again, we select three components, and this button creates a joint placed in the middle between first two joints, but as close as possible to the third one. It's a bit difficult and kind of specific functionality, but what can it be used for? Very often you need to create eyelids. It means that you need to position joints in a very specific place in order to slide your eyelids along the surface of the eye. And very often you need to connect both eyelids, so those eyelids need actually they need to stop at the same position. It's not often the case, it's not often possible, because sometimes 3D artists model things in a very specific, unusual, let's say, manner, or not really convenient manner for the rigger. And most often this point it's not the same point as the center of an eye. So what can you do? You can select some faces directly, or essentially you can create some temporary joints. So right now I'm selecting the components for my eyelids, for the both upper and lower eyelid. Let's say those faces, I think they're going to be fine. Then I'm selecting the center of rotation for this eye. And then we're going to apply this function, and you'll see that we have a newly joint created, but it's not very slightly not the same position as the center of an eye. So it has slight offset, sorry, but it's a perfect position for closing and opening the eyelid. So again, it's in the middle between the first two selected joints, and as close as possible to the third selected object or the third joint in this case. It is a rather useful tool because it saves a lot of time. I think at this point I've covered almost all the necessary functionality, all the buttons. There are still a few, but I think you'll be able to figure out those by yourself. They're not actually really difficult, especially if you worked with the rigging before. And as a little bonus, let's actually create a normal skeleton for the arm. And this model is a classical example of this confrontation between riggers and modelers and 3D artists, I mean, because riggers highly prefer, really like for the fingers to be straight, like exactly straight, because it's easier to rig. But 3D artists rather prefer to create the model in a more relaxed, to create the arm in a more relaxed state, because it is easier to maintain the shape of the fingers. It's anatomically a bit more pleasant to look at. To be honest, I'm with 3D artists on this part, because I, as a 3D animator, highly prefer working with relaxed hands, relaxed arms, because they maintain the shape, they maintain the volume, necessary masses. Just it's more convenient for me. Let's try placing joints in this hand. It's going to be a perfect example for using our tool set. So let's make it quickly. Let's say most likely we're going to have I'm going to place a joint over here. I'm going to place it approximately for now, and then tweak it slightly a bit later. Then I'm going to do the second finger. Yeah, maybe something like this. I'm going to leave the thumb for later. First I'm going to work with the 4 main fingers. Alright, we positioned our joints. Of course they're kind of in the wrong positions right now. Let's actually move them inward slightly. In my experience, it's better to position joints for, let's say, game models, game hands, closer to the outer edge of the model, so kind of closer to the outer surface. So somewhere around here should be fine. We also can use the after plane function in order to position the joints on one plane, or we can do it in a proper manner, in a proper way. Let's do it manually. I'm going to place it like this. So this plane should be rotated, usually it should be perpendicular to the finger, to the surface of the finger, so let's try tweaking that. And usually you have to think about a few things when you're positioning, when you're orienting your joints for fingers. The first idea is that your fingers are supposed to be rotating inwards, so it's kind of inwards towards your palm in order to make a fist. Second point is that your plane should be positioned something like this for the first finger, and then I'm going to show you for the rest of the fingers. It's kind of a bit of a separate topic, so I'm not going to talk about it in a very deep manner. Okay, for now let's tweak the joint positions separately. I think we can do the second one as well. I'm gonna make a plane slightly bigger just for the convenience of working for now, because it's a bit more representative to work with. Then manually I'm gonna tweak all the joints like this. Yeah, I guess that's fine. That'll do. Alright. Okay, purely based on we position joints purely based on the model of this hand. Let's do the same with this joint chain. First I'm going to tweak these joints. Alright, positioning the joints like this. This finger is going to be at a slightly different angle. Again, the idea is that the finger should rotate inwards towards the palm. You see the benefit of using the plane and orienting the joints based on the plane, because it's easier to understand how these joints are going to rotate inwards. You see the intersection of the joints. Let's move it like this. Okay. Yeah, this one, yeah, she should have a very rather steep angle. Yeah, I think this angle should work very well. Okay. We can also tweak the joint positions for the pinky and for these joints in order for them to be kind of in one line. Yeah, I think like this will work beautifully. Again, we can make exactly the same positions over here as well. In order for them to be in one plane, like this. Yeah, I think that's fine for now. After that, I'm gonna select the joints, deleting these plain helpers, so to speak. After that, we can orient the joints. I think in this case I'm gonna use the X value for the joints. I have a hotkey set up for the select hierarchy button, so that's why I'm selecting the hierarchy without pressing any buttons, as you can see, just in order not to confuse you. Alright, and my joints are oriented, positioned very well. Now, for the first joints, we can transfer the rotation channels to the joint orient channel. And then, if I select all the rest of the joints, or the rest of the fingers, I can zero out those rotations, and you'll see how they're kind of straighten for now. And it's very convenient for the animator and for the rigger to work with. We can rotate those inwards if needed. And when we rotate our fingers, how it actually works. When we start rotating our fingers, they rotate in its own planes, so it's anatomically fine. But at a certain point, the middle finger is continuing to bend, to rotate in the same direction, but the rest of the fingers, since those fingers are about to kind of collide with neighboring fingers, they anatomically change the axis of rotation just slightly. But that is just something I wanted to talk about. And generally speaking, you can see that the skeleton is done. It was rather quick using this tool.